So today we'll be looking at factory method, factory pattern, and like before diving into the what uh, design principle I learned, let's first understand uh, what a factory is, because if I directly state the principle, then it will be difficult to understand. Okay, so let's understand what a factory is. Factory. So it is a way of creating concrete objects. Okay, it is just a way of creating concrete objects. Okay, and factory is like, it's not a design pattern. It's not a design pattern. It's a programmatic idiom, which means that it's just a way of doing stuff. So let's understand a simple factory by looking at the code. Okay, so let's say that I have to create some pizzas. Okay, and like let's first create a pizza interface pizza. Okay, and what will it contain? Let's say, okay, let's abstract it out. It contains something. It's a black box for us. Okay, so let's say that I have to create a pizza, and let's say we already have a pizza creator. Okay, let's say that it knows how to, we need to bake a pizza, we need to prepare a pizza, we need to pack a pizza, and we need to deliver the pizza. Okay, so we earlier had pizza creator class. Okay, now what it does is basically, okay, what it does is basically, it contains a method void order pizza, right? And it will return me a pizza. Okay, it will take a type. So type could be like, let's create type first. Pizza type. Say cheese, paneer, veggies, non-veg, and What else? Pizza, cheese, veggies, non-veg, and let's say pepperoni. Okay, so these are pizza types. So it takes a pizza type. Pizza type. And what it does is basically let's create some pizzas as well. Let's say cheese pizza extends pizza. Okay, similarly we can have, let's say, veggie pizza. Similarly we have non-veg pizza and pepperoni pizza. Pepperoni pizza. Okay, so let's say that we have these types of pizza. So when we order a pizza, what we will do, we'll create a pizza, right? If yeah, let's use switch type and let it implement for us. Okay, so case cheese, we will have pizza equal to new cheese pizza. Then we have similarly pizza is equal to new veggie pizza. Non-veg, we have pizza equal to new non-veg pizza, and this is equal to new pepperoni pizza. Okay, and once we have the pizza, what all steps are included? So we prepare the pizza, we bake the pizza, we can't pizza the pizza. So okay, we cut the pizza, right? We cut the pizza and we also pack it in a box the pizza. Okay, so we do all these steps. So once you do this, we will basically do the same dot. We will prepare the pizza. We will pizza dot bake the pizza. Let's initialize it with a null. Okay. And case. Okay, if okay, done. Okay, now we will cut the pizza. We will box the pizza and then pizza dot we will deliver the pizza. Okay, and we will return the pizza. Okay, so what we can see here is basically this part is varying. What it is doing is basically creating new objects, right? This new basically creates a concrete object. Okay, so let's look at our notes again. Okay, so we learned that we learned what to do. We learned to encapsulate what varies, right? So right now our creation logic is varying. It creates a different pizzas, right? So let's take a look at that. So this creation logic should be separate. That's what we know, right? So let's say we separate it out in a function. Create pizza. Okay, so we will pass a pizza type to it. Pizza type, and it will basically create my pizza for me, right? And we will return the pizza from here. Return pizza, and here what we will do, we'll just say pizza equal to new not new, just say we will say create visa and we'll pass the type to it, right? So we basically encapsulated what varies, just follow the earlier design principle, nothing new. Now let's say that I put this into a new class, class simple pizza factory. Okay, so and I pass it, let's say the factory, simple pizza factory. Then what I will do, I will I will say factory dot create pizza. So this becomes my simple factory, right? And like this is not a design pattern as such, it's just a way of doing like things. We just encapsulated the creation logic and placed it into a separate class, so it's not as such a design pattern. Okay, so this was about uh, simple pizza factory, or what a simple factory would be, right? Now let's come to the design pattern, and then we will discuss about the principle it is solving, otherwise we won't be able to understand. Okay, so okay, so now we will first start with the factory method. Let's start with the formal definition of factory method. Okay, so it defines an interface for creating an object, but let the subclasses decide which class to instantiate, which class to instantiate. Okay, so we can also say it differs the creation to the subclass. Okay, let's understand what it is saying. So basically what is say, it defines an interface. Now interface can be abstraction as well, like it can be an abstract class or it can be an interface for creating an object. So basically for creation logic of an object, but let the subclass decide. So in our logic, the original class was defining what pizza it needs to create, but in this case the subclass will decide which class to instantiate, which class to create. So it basically differs the creation logic to the subclass. I mean, this is the summary. It differs the creation logic to the subclass. Okay, so let's create the factory method pattern. Mm, so like this was our original pattern, but what now we will do is basically pizza factory, and it would be an abstract class pizza factory. It will, what it will have, mm, so it will have the order pizza method, because that's a standard method that everyone needs to follow. Okay, now we won't require a factory here because we already have a factory, we are in a factory. So we will have a create pizza method, and this create pizza method would be abstract pizza create pizza. Okay, now okay, okay. Now what I can do is, let's say that what was the need for it. So the basic need for it was, let's say our earlier factory was tied to a single creation logic, so it was not very extendable. Like if I need to create let's say a Punjabi pizza, then I would have to add the method there only, right? Yeah, I would have to add the method there only. Okay, let me try to do it. Yeah, so like let's say if I have to create a Punjabi cheese pizza, then it would not have been possible with this, right? What I would rather do is we will move to the current logic. Okay, and now I can create a Punjabi pizza factory. So let's create a Punjabi pizza factory. Abstract class Punjabi pizza factory. Not this one would be not be an abstract. Okay, Punjabi pizza factory, and it will take pizza type. 1 second. Okay, and we can just say Punjabi pizza factory extends pizza factory, and I will just implement the methods, that is create pizza. Now I will just say switch type. So in cheese pizza, let's say this was pepperoni pizza, right? We can just create a new pizza which is Punjabi pepperoni pizza, right? And we can copy all this. Punjabi veggie pizza, Punjabi cheese pizza. Yeah. And what this factory will do, it will just say, give me a second. Pizza equal to new Punjabi cheese pizza. Okay. We have new Punjabi veggie pizza. So equal to new Punjabi non-veg pizza. Egg pizza equal to new Punjabi pepperoni pizza. Right. And at the end we will return the pizza. Similarly, we can have Delhi style pizzas as well. So just copy this. I will just say this would be a Delhi pizza factory. Okay, I will create more pizzas. I will create Delhi non-veg pizza, Delhi veggie pizza, Delhi cheese pizza, Delhi pepperoni pizza, Delhi non-veg pizza, and Delhi veggie pizza, right? Weird. Hmm. Okay. Now instead, what Delhi Pizza Factory will do, it will create Delhi cheese pizza, veggie pizza, Delhi non-veg pizza, Delhi pepperoni pizza. Right. So this is my Delhi Pizza Factory. This is my Punjabi Pizza Factory. Okay. So how will we use this, right? So let's say that if I have to So I can basically, what I can do, uh, let's go to main method. One second. I will go to main method. I will say pizza factory equal to new, let's say Punjabi pizza factory, right? And I will just say pizza factory dot create pizza, and I will pass pizza type dot, let's say cheese pizza, right? So this will create my Punjabi pizza factory. Let's say that I want to create another factory, that is Delhi pizza factory. So Delhi pizza factory which is equal to new Delhi pizza factory, then Delhi pizza factory dot create pizza. One thing it can do, we can just say private. Why I would, okay, 1 second, I can just say, can I make it private? Yeah. So I should not, right? So the main, I would not do this. I would order the pizza. Now it's good. Okay. Yeah, order pizza, like say pizza type dot non-veg pizza. Right. So what? Let's just implement something. Let's implement these. Yeah, my bad. Hmm. Okay, so it will implement the pizza, and in prepare, let's say we have system.out.println preparing Delhi non-veg pizza. Okay. Baking at, let's say, what, 180 degrees Celsius. Okay, and cutting in diagonal manner. Okay, and then this will be packing in official boxes. Okay, so let's copy these steps everywhere. Implements method. Okay, yeah, this took some while, but yeah, so implemented all my pizzas. Now, if I go here, I will run this program. Okay, so it will say preparing Punjabi cheese pizza, baking at 180 degrees Celsius, cutting in diagonal manner, packing in official boxes. Then I will preparing Delhi non-veg pizza and baking at 180, cutting in diagonal manner, packing in official boxes. So this is what we call a factory method. Now we will move to the design principle of today. Okay, so it will be dep dependency inversion principle. What it says is depend on abstractions, do not depend on concrete classes. Okay, so this one is same kind of this from this one. Program to interface, not to implementation. What is the difference between the two? What is the difference between the two, right? So the main difference is this one says depend on abstractions, whether it would be a low level component or a high level component. Like in our case, both the pizza, like the pizza implementation and factory, both were depending on the pizza, right? Because factory required pizza to generate the pizza, and pizza implementation obviously required pizza to create one, right? So in simple factory, what was happening? Okay, so in simple factory, what was happening? We had a pizza factory, right? Simple pizza factory, and it was not depending on the pizza, right? It was just depending on the implementation. So it was depending on pizza implementation, and it was creating a pizza from that. Now this was a like a straight pattern, right? So this was a straight dependency, and this pizza factory was then depending on our, let's say, pizza creator. So our pizza creator depends on the simple pizza factory. That's it, right? And it was not directly depending on the pizza. The pizza factory was not directly dependent on the pizza. But here the dependency got inverted. What happened was that we have our original pizza, right? Both our factory, like what we created, abstract factory, right? Both our not abstract factory, factory method. Both our factory method and our concrete classes. So uh, factory method and the concrete classes, both were dependent on pizza. So here the dependency actually got inverted. That's why it's known as dependency inversion principle. Okay, and then it says depend on abstraction, do not depend on concrete classes. So it says the same, like program to interface, not an implementation. But here the important part to notice that both our high level components and our low level component, they should both be dependent on abstractions. So our high level component high level component, oh my bad, our high level component and our low level component, the concrete classes, both are dependent on the abstractions. Okay. S- so that's why this like this principle goes a further deep. Okay, so that was the factory method pattern. Let's move to our next factory pattern, that is abstract factory. Abstract factory. So what is abstract factory? So it provides an interface for creating families of related or dependent objects without specifying their concrete classes. Okay, let's understand what it says. So basically, earlier what we were doing was we were creating a single object, right? And then our subclasses would decide which one to instantiate. Here we are creating a family of objects, right? And we are not like like we are not specifying their concrete classes. So let's take a look here what we are in the code, what we are doing. Okay, so this was our pizza factory, which was a factory method. And what we did was let's create a okay, let's create a scenario for us. So let's say that uh, Punjabi pizza uses different set of ingredients compared to our Delhi pizza, right? So for example, Punjabi pizza may use a wheat based dough, while the Delhi pizza may use a uh, some other dough, right? Maybe let's say that it uses a atta dough, and Delhi pizza would use a maida dough. Okay, so now we need to create a factory to supply the ingredients, and which ingredients it would use. Okay, so now our pizza will also take a ingredient. So let's create a ingredient factory. uh, uh, let's create it here. Interface. Let me just think. So interface pizza in ingredient factory. Ingredient factory. What all goes into making a pizza? So we require a dough, right? And sauce. We will require a sauce. We will require what else we require? A cheese. Okay. What else we require? We will require, let's say, veggies. Okay. No. And now we have to create an implementation of these. So let me just create. Let's do it in a separate class. and veggies, right? Okay, so we all have our all the ingredients ready. We also need to like provide this to the pizza. So pizza would have to contain a dough. It would contain a dough. It would contain a sauce, right? It would contain veggies. It would contain cheese, right? Okay. Now what we will do is we will create the ingredient factory. Then we have to pass that ingredient factory to our like pizzas. So now the distinction is also over. Like we don't need to like create 4 units of these by creating Delhi or Punjabi pizzas. We know that they only vary by the ingredients. So we will just create non-veg pizza, veggie pizza, cheese pizza, pepperoni pizza, right? We only need this, and these all variants will be out. Okay, so see our code has also reduced. Now these will only vary by the ingredients they have. So we have a pizza ingredient factory. Okay, so this I'll just say it as ingredient factory and one second. Pizza. Okay, so each pizza will have an ingredient factory which has to be passed in its constructor. Take pizza. Okay, now in ingredient we can just say so this will be, let's say, yeah, we won't have to create new because like we have ingredient factor dot create dough, right? Then we will have sauce which is equal to ingredient factor dot create sauce. Then we will have cheese which is gonna have ingredient factory dot create cheese. Then we have veggies, ingredient factory dot create veggies, right? So this will be the prepare method for this. And same will go for others as well. One, two, three, four. Okay, now we will just copy paste this boilerplate code factory, and when passing taken factory. Fish pizza. Oh, my bad. Okay, now we will create the actual factories, the ingredient factories. So the let's say class Punjabi ingredient factory extends or implements pizza ingredient factory. So implement methods. So in the dough it will take return atta dough. Hmm. Okay, return new will take more tomato sauce. It will return new paneer cheese. Return new veggies. We can just say capsicum veggie. Okay, I think this is how I initialize that is right. Hmm. One minute just. Hmm. Weird. Okay. 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 Yeah. So our Punjabi pizza will take Punjabi ingredient factory will take a capsicum and tomato, while our Delhi, let's create a Delhi factory for Delhi ingredient factory. We'll take a maida dough, we'll take a mayonnaise sauce, we'll take a mozzarella cheese, and in veggies it will only have a tomato veggie. Yeah, so this is Delhi ingredient factory. Then we have, now we can basically supply these ingredients to our pizzas. So when we are creating a Punjabi pizza factory, right, we can just say we will take our type, right? So and here we will initialize the ingredients as well. So Punjabi pizza will take Punjabi ingredients, right? So we will have a pizza ingredient factory is equal to new will be Punjabi pizza factory. So new Punjabi ingredient factory. Hmm. Now what I will do is just I will pass. Now there's no meaning of this. There's no meaning of this. Okay. And for Delhi Pizza Factory, we'll create a Delhi ingredient factory. Hmm. So our nothing has changed. Like the core, how we used to access it remains the same. It just we have internally changed the methods, right? So preparing cheese pizza, atta dough picked, atta dough picked, tomato sauce picked, paneer cheese picked, capsicum veggie picked, tomato veggie picked, baking. Okay, let me just do one thing. I think I forgot to put L in here. Yeah, let's see, run this program. So what it says, preparing cheese pizza. So first would be Punjabi cheese. So we will atta dough picked, tomato sauce picked, paneer cheese picked, capsicum veggie picked, tomato veggie picked. Baking at 180 degrees Celsius, cutting in diagonal manner, packing in official boxes. So this creates my Punjabi cheese pizza, right? And then Delhi Pizza Factory, preparing non-veg pizza, maida dough picked, mayo sauce picked, mozzarella cheese picked, tomato veggie picked, baking at 180, cutting in diagonal manner, packing in official boxes. So so this was my abstract factory method. Basically, we created family of classes, uh, family of objects here. Yeah. So here we create family of objects, and then the concrete implementations would determine what all the ingredients we need to prick. Okay. So that's what the definition we checked as well. Provides an interface for creating family of related or dependent objects without specifying their concrete classes. So this was all about the factory method pattern, where we saw about simple factory, we saw about factory method, and we saw about abstract factory. Okay, let me just check. Did I miss anything? Yeah, so we have covered everything. Okay.